In this video, we will practice graphing sine and cosine with changes in amplitude, phase shift, and vertical shift. I encourage you to pause the video before each example and try to do the problem by yourself, and then start the video and see how you did. The first thing I like to do is factor out the b value. This number here in the front, I'm going to refer to as the a value. But this number right here, right in front of the x, is what I call the b value. Right now, we have this b value in front of the x, and then we have minus pi. We really need to rewrite this with the b value factored outside of the parentheses. So I'm just going to recopy it down here. I've got 4x minus pi. If I want to bring that 4 outside of parentheses, I need to divide everything by 4, and that will tell me what goes inside the parentheses. So obviously the 4's will cancel, and that's going to leave me with x, but then I see that I have x minus pi over 4. So this expression is the same thing as what I had, but this is the way I really need to write it in order to be able to see the phase shift. So I'm going to rewrite the equation as y equals 2 sine, and now I'm going to have my 4 times x minus pi over 4 plus 1. So right away that allows me to see the phase shift, which is right here. It's the pi over 4. The phase shift is always going to be the opposite of what you see. If I have a minus pi over 4, that means that the phase shift is pi over 4. If this were a plus pi over 4, the phase shift would be a negative pi over 4. Okay, so the phase shift is pi over 4. That's really the most important thing, because that is going to be the first mark that you put on your number line. So I'm going to go ahead and put pi over 4 right here, because you're always going to start at your phase shift if there is one. So there's my pi over 4. Next, I need to figure out what the period is and what the quarter period is. So for the sine function, the period is usually 2 pi. But if you have a b value, then the period will be 2 pi over b. So in this case, the b value is 4. So that means that the period is going to be 2 pi over 4. So that's going to simplify down to a period of pi over 2. So that's one of the things that we are supposed to write down. So the period is pi over 2. We are going to need the quarter period, because that's how we will put our marks on the number line. We're going to record a value every quarter of a period, because that's where the key changes happen with the sine and cosine graphs. So obviously the quarter period is the period divided by 4. So I've got the period. I'm going to put QP for the quarter period, and if I want to divide this by 4, the easiest way to divide a fraction by 4 is just to put an additional 4 in the denominator. So the quarter period is going to be pi over 8. All right, keep that in your mind. Let's go ahead and put 4 additional marks on our number line to represent every quarter period. So I'm going to put a quarter period right here. So that'll be 1/4 of the period. And right here will be another quarter period. Okay, so that's half of the period so far. This is 3/4 of the period, and then the period will end here. So I'm putting 4 additional marks because I have 4. I'm dividing up the whole period into 4 equal parts. So because I have 4 equal spaces, if I start from the phase shift, I should be able to find out what the next number is by adding the quarter period. So I'm going to start with the phase shift of pi over 4, but I'm going to add the quarter period of pi over 8. Okay, I'm adding the quarter period. That should give me the next value. But I need like denominators though. So let's see. I could make these both be in terms of 8. So let's go ahead and multiply by 2. So we have like denominators. So this will be 2 pi over 8. And maybe I'll just erase it to make it really clear. So this quarter period of pi over 4 is the same thing as 2 pi over 8. So if I add pi over 8, that's going to give me 3 pi over 8. So that's going to be the next mark on my number line. Okay, a quarter period later, I have 3 pi over 8. So let's continue and keep adding a quarter period so we can find the next position and the next position and the next position. So I'm going to add another quarter period, all right, another pi over 8, and that's going to give me 4 pi over 8. All right, 4 pi over 8 reduces down to pi over 2. So I'm going to go ahead and put pi over 2. Now let's add another quarter period. So we're adding another pi over 8. So that's going to give me 5 pi over 8. All right, so I'm going to have 5 pi over 8 right here. So let's add one more quarter period. All right, and that's going to give me 6 pi over 8. But that reduces down to 3 pi over 4. So the period will end at 3 pi over 4. Time to draw the y-axis. Since pi over 4, positive pi over 4 is right here, I know the y-axis will be somewhere to the left of that, so I'm just going to go ahead and put it over here on the left. I really need my y-axis at this point because I need to pay attention to the vertical shift. This +1 on the end tells me that there is a vertical shift of up 1. So because of that vertical shift, I'm going to go ahead and mark that on the y-axis. So here's 1 right here. And this is going to be the new midline. So we should make some sort of a dotted line to show that this is the midline. I might cheat though and use my line drawing tool because it would be helpful if this were like a pretty straight line. Okay, so this is going to be my new midline, but normally we would draw a dotted line right here for the midline. So I will use this as a guide. All right, so that is the new midline, and that's one of the things they wanted me to write down. So horizontal lines have the equation y equals, so I'm going to say y equals 1. Now it's time to pay attention to the amplitude. This a value is going to tell me the amplitude. The amplitude is always positive, by the way. So the amplitude is going to be 2. But even if this were a -2, I would still put +2 for the amplitude. The amplitude tells you how far above and below the midline the graph will go. So since the amplitude is 2, that tells me I need to go 2 units above the midline. Okay, so if this is 1, this will be 2, and this will be 3. So I need to record that. So if this is 1, the graph will also go below this by 2 because of the amplitude. So I'm going to go down 2, so this will be 0, and then -1. Okay, so this will be the lower bound of the graph. So I'm going to put a couple of additional guidelines to help me draw. These lines are optional. So I'm going to make them yellow. I'm intentionally making them hard to see because they're not actually part of the graph. They're just guidelines. But this is to remind me that there's my upper boundary of the graph, and this will be the lower boundary of the graph. Okay? Now, remember that the graph is always going to begin at the phase shift. So the pi/4 is where we will begin. And a long time ago, we memorized that the sine function, all right, that's the type of graph we're graphing, the sine function begins on the midline. So I'm going to put my first dot on the midline at the phase shift, and then the sine function rises to its highest point, all right, after a quarter of a period, and then it falls back to the midline a quarter period later, and then it falls to its lowest point a quarter period later, and then at the end of its period, it goes back to the midline. So these 5 key points show me what the graph is going to look like, and I can simply sketch the graph now through those 5 points. All right, there you go. There is one period of this sine function. Let's do example 2. Again, I encourage you to pause the video and try to do this problem by yourself first, and then watch the video to see how you did. The first thing I like to do is to factor out this b value that's right here. I want to factor out the b value. So I'm just going to use this as scratch paper for a moment. So I have 3x minus pi/2. But I really would like for that b value to be outside of the parentheses. So to make that happen, I need to divide everything by the b value. I need to divide both terms by 3. So these 3's will cancel out, and that will give me x minus. So what's pi/2 divided by 3? Remember, when you divide a fraction by a number, just put the number in the denominator. So this will be pi/6. So I'm going to rewrite this function as y equals 1/2 cosine. Okay, and I'll have 3 times x minus pi/6 minus 1. So in this form, we can see what the phase shift is. The phase shift is the pi/6 right here. All right, it's always the opposite sign. So because I have a minus here, then my phase shift is a positive pi/6. But just be aware, if this had been plus pi/6, then my phase shift would be a negative pi/6. This is super important because we always begin the graph at the phase shift. So I'm just going to put a pi/6 right here somewhere, and that is where my graph will begin. It's all about quarter period, so I'm going to put 4 additional marks on this graph, and every mark represents 1/4 of the period. So I will have a quarter period here, 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 and here. So altogether, these 4 marks will represent the entire period, but 1/4 period at a time. if I'm going to find the values at these 4 marks, I need to know what the quarter period is. So for starters, I need to know what the period is. So remember, the period of a cosine function is normally 2 pi. But if there's a b value present, and here the b value is 3, then the period will be 2 pi divided by that b value. But we need to know what, oh, well, that's one of the things we're supposed to write down. So the period is 2 pi over 3. But we need the quarter period in order to find the value of each one of these positions. So to find the quarter period, which I will call QP, we need to divide by 4, obviously. So if I divide by 4, I'm just putting a 4 in the denominator. So the quarter period will be 2 pi over 12, which equals pi over 6. So that's a quarter period. All right, I'm just going to put this off to the side to remind me that the quarter period is pi over 6. All right, I'm going to erase this little scratch work right here. So it's time for me to find the values of these other positions. So I started with the phase shift of pi over 6. If I add the quarter period to that, it should give me the next position, which is 1 quarter period over. So I'm going to add pi over 6. So that's going to give me 2 pi over 6, which reduces down to pi over 3. So this position will be pi over 3. To find the next position, the next value, I need to add another quarter period. So I will add another pi over 6. So that will give me 3 pi over 6. But that reduces down to pi over 2. So this will be pi over 2. Time for the next position. I will add another quarter period. Okay, that's going to give me 4 pi over 6. That reduces down to 2 pi over 3. Okay, and finally, if I add another quarter period, that's going to give me 5 pi over 6, which does not reduce. Okay, so I see the positive pi over 6 right here. So I need to place the y-axis somewhere to the left of that. So I think I'll just put the y-axis way over on the left. So I'm just going to put the y-axis right here. I'm going to need the y-axis because it's time for me to record the midline. This -1 tells me that there is a vertical shift down 1. So that's why I'm going to go down 1, which I'll put right here. So here we have -1, and this is going to be the new midline. And I'm going to put a guideline for myself to represent the new midline. So instead of the x-axis, this will be the midline. And we should express this as a dotted line, but I put my little midline there as a guide. I put the blue line to help me draw straight. Okay, so there's my midline, and that's one of the things they want us to record. So the midline is y equals -1. Now let's pay attention to the amplitude. So the amplitude is the 1/2. Okay, it comes from this a value right here. So the amplitude is 1/2. Please keep in mind that the amplitude is always positive. So even if this were a negative 1/2, I would still put positive 1/2. The amplitude tells me how far above and below the midline I'm going to go. So just as a frame of reference, obviously the x-axis here is at 0. I'm going to go down a full unit and put a -2 here. So, since the amplitude is 1/2, the high and low of the graph will be 1/2 of a unit above the midline and 1/2 of a unit below the midline. I'm going to go ahead and put a yellow line as a guide to show this. So here we are 1/2 of a unit above the midline and 1/2 of a unit below the midline. Okay, we have learned that the cosine function always starts at its highest point. So we begin at the phase shift of pi over 6, but the cosine function will begin at a high. All right, so I'm 1/2 of a unit above the midline. And then a quarter period later, the cosine function falls to the midline. And then it continues. A quarter period of later, it's at its lowest point. And then it rises back to the midline. And then it will end at its highest point. So one period of the cosine function will look like this. Okay, that was not the smoothest graph, but you get the idea. There, that's a little bit better. Anyway, that is how you graph a cosine function with a change in amplitude, midline, and phase shift.